Hi. Last time I talked about PCB testing, building the continuous cycle of testing to verify the circuit really made me think again about unit testing for the firmware. I've been a great fan of test-driven development since I got into agile development in the year 2000. On the Pico, I've been doing an ad hoc TDD process, reinventing my test framework each time, which isn't efficient. I've decided to try to move towards a standard framework and chosen CPPU Test. This video is going to be about the setup of a project to include unit tests, using CPPU Test and running that on the Pico. Please don't forget to like the video and to subscribe. I really do appreciate it. Since getting into agile development, I've been a fan of test-driven development, TDD. So, I do my design, and the first thing I then do and take from my design is to write a set of tests. So that helps me really conceive what the interface is to my code and how I'm going to stimulate that code and get the desired result. I can then write the code to actually pass that test and then execute that test. And of course, things don't go quite as I perceive, so we generally end up going back into doing a little bit of redesign, rewriting some of the tests or writing some additional tests, because every time you make a failure, you write an additional test to demonstrate that, write some more code, and we go around that cycle. So how do I then bring that world into the world of Pico development in C and C++? Well, we really need to be able to build two binaries from a given project. My clean application code that's going to go off and do whatever it's going to do and provide that wonderful experience, and my test set, which is just going to run through all those tests and tell me if it passes or fails. So both of these are going to run on the Pico, and that's really key because that's what I want to test. So I can write tests that are actually going to test out various modules or that I'm interfacing into the Pico. Now, of course, for some things, we might actually end up with some more complicated tests that actually I don't need to run on the Pico at all. If it's just a random number library or it's just some numeric library that's doing some calculations or some modeling, then actually I can probably test that away from the Pico and actually run that on my laptop itself. Today, I'm only going to really talk about a structure where we can build a clean application to run on the Pico and the test set to run on the Pico. Running code and mocking up to run on a laptop is beyond today's video. Of course, I have been doing test-driven development on the Pico for a while, and with everything I write, it tends to be the way I work. So I tend to write tests and test harnesses around my code, but they've all to date been very DIY efforts where I sort of invent the code every time I write it. And that's a very amateur way of doing this, really. Running DIY TDD framework is pretty easy, and I invent it all the time. All I need is some function or class that's going to set up the test condition, run the test, and then tear down any things we set up. And then capture some stats around whether that test passed or failed so that I can report on it at the end. That's all I'm doing in those tests. But actually, I can use frameworks that can do all of that for me. One example of that is CPPU Test. And I've been trying to get that to run nicely on the Pico so that I can actually migrate to that. That has some advantages because it has some additional standard testing that I can get running in the background. Things like memory validation to make sure that actually I don't have memory leaks. Now, it's lovely to have that done as a test framework around my code. All of the code I'm going to talk about today is all available on GitHub, so you can clone it and have a look at what I'm doing. It is only a framework, though, that I'm trying to reuse there that I intend using to base my future projects on. Right now, the template project I've set up is bare metal only. It can only run with a standard SDK for the Pico for C or C++. I do want to extend that because a lot of my projects actually use FreeRTOS. So I need to do some more work though to get things like the memory management testing working nicely on CPPU Test, and that all working under FreeRTOS. I'll tell you when I do that. Right now, what I'm talking about today is going to be around bare metal. So what we want is to still be able to build our clean application by typing make, just as we normally do. But I'd also like to be able to issue the special command make test and build a new binary that actually is going to run all of my unit tests and give me the test report for that. Both of them should be based on the same pool of code that is being executed, because that's the point of testing, isn't it? You're testing the code that we're actually going to run in production. So to do this, I'm going to extend the project structure a little bit, and as well as my source folder, my libraries folder, my port of those libraries folder, I'm going to add a folder called test, and it's there that I'm going to include a new main application which is just going to run all those unit tests and all the test cases that are going to be run. So over in Visual Studio, let's have a look at my template project for a bare metal project for doing this unit testing. So first of all, let's talk about the clean build and any changes to the clean build, because there are a couple. So first of all, my clean build, just as before, is in the source folder, and we've got a CMake file in, or make list.txt file here, that is just the normal structure for a project. So I've set up a project here, I'm adding executables, adding libraries, telling it compiler definitions, telling it where I want my standard IO to go, all of the normal stuff I would put in the CMake list file in my source folder. Slight change here is that I am using for the additional libraries or additional classes and files that I want to build into this executable, I'm actually defining them within a variable. And that variable I'm defining in the files.cmake file. The reason I'm doing that is so that I can pull that same list into both the unit test side and here. Now, the one thing that you need to be careful of is we don't want the main program for the for our clean build to be included in that list. We're just talking about all of the component parts that we're actually going to test. But apart from that, everything in the source folder is just the same as it would be in any other project. Up at the top level, we've got a little bit of a change in the CMake file up there, because we need to add a additional subfolder into our build, and that additional subfolder is test, and we're going to exclude that from the all build. So when we type make, this stuff isn't going to get built unless you actually type make test. Anything in this test folder doesn't actually get built and added in. So that's what we've done, and that conforms to what I've just told you about, typing make test to build our tests. So really, the other changes are all inside test, and the make file here is going to set up some clever stuff. So it's first of all, it's actually going to go and pull CPPU Test directly from GitHub. So we don't need to clone it, we don't need to add it into our library, it doesn't need to be there unless we're actually running those tests. And it's only when we're actually running those tests that it goes and pulls all of this stuff down and runs the make for it and builds it. We're going to include the files that I've just set up, that's CMake file that is giving us the definition of all of the source files that are going to be included as part of our test. So our executable here then becomes our new main program, which is actually the main program to run the tests, a list of tests itself, and the source code that we actually want to test the libraries, the functions, the classes that we're actually going to run as the test. The rest of it looks very much just like a normal CMake file from a source folder. So let's have a look at what the tests look like. So if we have a look at a test here for my, and it's what I'm actually set up here as a test is a Fibonacci sequence. So I've defined a test, so we're pulling in a class called fib. So I'm finding a test group called fib group, and I'm only going to add one test to it, and that test is called fib test, and it's basically going to set up my fib object, and it's going to check a set of values. It's going to check that the first element in the sequence is 0, which is the element 0, element 1 within the sequence is 1, and the element 13, or element 6 within the sequence is going to be 13. So that's the test. That's the test we're going to run. We can also, I've done some additional tests here around things like a leak to actually cause my Fibonacci class to leak memory. So I can show you that actually leak causes an error to happen, and that's to see it, and a functional test here that's going to fail. So if we look at the 6th element of the sequence and look at a 10, that will fail. Functional failures within CPPU test are a little bit odd, I thought, when I first came across this, and it took me a little bit of investigation to understand why. If this functionally fails, all of the tests will get cancelled, and the code will throw an exception and stop. Now, that seems really annoying because I've got all of these other tests. They've not run. Okay, I know that one's failed, but how about all the rest of the tests? Well, the reason for this is, from a debug point of view, if you want to try and find out why that test failed and to trace into it, it's much easier if it actually completely fell over. Because then as soon as I run up the debugger, I've got a stack trace of exactly where it fell over and why. So that's why they've done it like that. It does make sense. And to be honest, you know, if the first error that happens, the first test that fails, I'm going to go and have to have a look at that test anyway. So it's sort of kind of irrelevant whether any of the other tests fail or not, because I've got to go and fix that one. So it does make sense. I do get where they're going, but it does cause some slight complexities. So my test program here, then main, really to run the tests, all you then do is issue the run all tests from the command line test runner. And it's really that easy to run up and do. I've been a little bit sneaky here, and I'm running my test twice. And I've given it some parameters for the first time so that it won't fall over and it will actually complete all the tests, because I've sort of told it to exclude the fail test. The second time I run it, it actually includes the fail test. So the first one, it will fail a test for a memory violation that actually has got a memory leak, and the second time it will fail a test because a functional test will fail. But that's it. Build is simple about your normal CMake and make structures, and we just do make test. That gets us our test.elf binary, and off we go to flash that over to our Pico and see what the test looks like as it runs. I'm going to run our unit tests. We're going to see the test run twice. The first set is going to complete, but one test will fail due to a memory leak. The second test, one functional test, will fail, resulting in an exception and termination. I think I've only done half the job on this so far, though I have the structure and I'm using it on some of my projects in the background. It really also needs to handle my FreeRTOS project structure though. I'm working on this and will update you when I have the template. Thank you very much for watching. Please like the video as it helps others find it, and please subscribe and hit that notification button so you don't miss my next video. Do take a look at my Patreon page too as well. I'd really appreciate your support in keeping these videos coming. Remember, Patreons get access to my videos up to a week early, and my personal gratitude. Goodbye for now.